record on.
Yeah. Hi, everyone. So today is March 9th, and this is SIG scheduling biweekly meeting. This meeting is recorded and will be uploaded to YouTube, so please adhere to Kubernetes Code of Conduct. We've got a few topics on the agenda. First one, Aldo. We have a race condition in pod info. And
yes,
add nominated pod.
Can you share the screen, or should I share my screen?
I'll give you so that you can navigate easier.
Okay. So basically, Patrick was working on dynamic resource allocation, and then he triggered his new tests trigger data race in scheduling. Wait 1 second, I'm just going to share my screen now. All right, so yeah, this is the issue. So Patrick found this data race while adding this new test. But after further analysis, this was not exclusive to the new test. It's just that the new test made it more easier to trigger. And Wei was able to. Was it Wei? Was it you or was it Patrick? You suggested to Patrick to try with the preemption path, right? The preemption test.
Yeah. So basically, his crew says, okay, maybe it's the first time we have a test to cover the code path, but I said maybe it's not because we have the preemption because that path is unschedulable, so it will be. So basically, the racing between two go routines. One is that a path is claimed as unschedulable, and then the other way, the event handler is updating the path. So these two go routines can race. So in some of the E2 tests, although not too much, like the preemption can also hit this kind of code path. So that is why he can reproduce that using the preemption test suite.
Sorry, the race is between the event handler and which go routine?
A path was claimed as unschedulable. So basically, patch the path status.
Right. So
the main go routine, that is.
So there is this routine that is writing, which comes from the scheduling events, the event handlers. And at the same time, there is a read from the scheduling cycle, which obtains the information about the nominated pods. Nominated pods. This one, right? Nominated pods for no. So that's the race that was found in both scenarios. Well, this changes in Patrick's scenario, but the update is the same, the same read. So after some debugging, well, Patrick proposed one solution, which was adding a lock or an atomic pointer. But we figured that might not be enough because there are other fields in the pod info that could also hit the data race. But we discovered that we have two objects. Where is this? So we have two objects in. I think it's this one. Yes. We have two locks, different locks between two objects, the pod nominator and the scheduling queue. And they both share the same pointers towards the queue, the pod info that holds the information about queuing. So So basically, the proposal that I came to is that we somehow make those two objects use the same lock. Here's the PR. Wei was able to test it with the preemption path, and it seems to solve the problem. Patrick still going to test it against his new tests. But also I want to write a specific integration test, hopefully to trigger this reliable before the fix. And that's the only thing that is holding me from merging this PR. So I'll add the integration test, and then they should be ready for merging. There was some discussion about whether there are other possible data races. For example, when popping an element from the queue, when popping a pod from the queue, we use that same pointer in the scheduling cycle. So there was a question about whether that could trigger another database, but it turns out it's not a problem because precisely we're popping out of the queue. So if there is an update that comes from outside that comes from the event handlers while we are scheduling, well, there is no object in the queue, so there wouldn't be there wouldn't be a write in place, right? So that should be fine. And also, if that was the case, we would probably have found the database way earlier. So I think I feel pretty confident about this fix. But as I said, I will add the integration test. If you have any questions, please don't hesitate to put them in the PR or any other concerns. We will cherry pick this to any versions. I think all versions are affected by all supported versions are affected by this data race. And that's it about this point, unless there's any questions.
Yeah, the solution looks neat to me. It's just the integration test. So in our CI pipeline, did we enable the dash race for all the tests, both unit tests and integration tests? We should check.
I'm pretty sure we do, but I'll double check.
Yeah, I think so. So yeah, we should.
I'll double check, but I'm pretty sure it does. Okay, so that's it for that point. Thank you.
Thank you.
Okay, so the second one is the Symboshi hosts a new alpha feature, and so basically the background is similar like what we introduced at the match label keys in the part topology spread. So we want to introduce to part affinity and part anti-affinity as well. So basically the logic are pretty the same. I reviewed the logic and there's a bunch of tests. So basically it looks good. So it's just, I think next Tuesday or sometime it will be the code freeze. So on my side, I will be able to approve this today or tomorrow, and then we need some API expert to review the API changes. That's pretty much the current shape.
Did you put in the API review queue?
I haven't. So basically I will give a /approve and then hand it over to API machinery. Yeah, but maybe just either in advance involve them. There's no harm. Yeah, that's for this issue. It's pure.
Sounds like a major PR. I'm just going through this one.
Yeah, but if you exclude the auto-generated changes, the core logic is just not too much. A lot of tests.
Quick question about the API.
Mhm.
So previously, I suppose the label selector was mandatory. Oh, actually, no, right? The label selector
No,
is mandatory. Okay.
but usually for Power Affinity and Power Affinity, you should specify a
Right.
selector.
Otherwise,
Otherwise, doesn't make sense. Yeah.
is it no pod matches or every pod matches if you don't specify?
I can't recall.
Mm-hmm.
I think it's match all. For example, if you specify Power Affinity, just a no OP, I think.
Okay, and then the two queries are ended. Okay.
Yeah.
I think I can give a review from API point of view, at least the first pass.
Okay. That's really good.
But I don't have time to check the implementation.
Yeah, basically, as long as the previous semantics are correct, what we did is to end the match labels, so it should be safe. But I will double check, yeah, whether it works with Neo Sector, Power Affinity, Power Affinity. Yeah, that's pretty much for this item.
Okay, thanks. Just related, there is also another PR that is related to sidecar containers. There's a refactoring that impacts how we calculate resources for containers. Let me put that on here. Just like in the context of overall, it's okay. It's always scary because these like refactorings can make changes to some assumptions and semantics. Hopefully, it's okay. It will be useful in the future as well because we had pod overhead and pod. What was the other one? The resize. We had to change things in multiple places. So hopefully this will help us in the future to centralize it. I don't think it did go all the way. There's still more room to improve, but I think they did enough. Aldo?
Are the scores calculated separately? Yeah, yes, because there was a default in the scoring plugins.
Yeah, I mean that's the one where exactly that's the one where it's like makes things a bit ugly. Like the non-zero thing, right? Yeah, that's the one that is still like a sore thumb in the way that we calculate things. It's but overall, I think they at least unified the way we iterate over the containers. Like we have the main containers, the init containers, and most likely in the next PR that they have is going to be the sidecar containers. So at least the iteration they unified over all places. But that specific one, yeah, they had to do a bit of quirky logic to basically take into account the non-zero defaults for scoring.
And the sidecar containers themselves are not coming in this release, are they?
Sergey mentioned there is a very slight chance. I don't know if they're going to get in the next 2 days. The main PR is up for review, I think. This one is a refactor that's supposed to make things easier for them.
I guess I would be concerned given that we just merged vertical in place auto-scaling.
Yeah. Yeah.
So maybe not.
That one is
ideal.
alpha. Both are alpha, right? Yeah.
Yes, but maybe one at a time would be better, given that they are so closely.
Yeah.
They are similar or touch similar places. That would.
Okay. Although pod group objects for MPI operator.
Yeah. So not sure if I don't want to spend too much time on this, but I wanted to share a discussion that we were having in MPI operator. So I guess let me share my screen again. So MPI operator and in general Kubeflow currently has support for pod group from Volcano, and the the main training operator, Kubeflow training operator, also added support for the cost scheduling plugin repo, the pod group from the cost scheduling plugins repo. And similarly, there is another open issue to add support for, what's this other one? Coordinator with a K. So basically, I'm not liking the idea that we dump a lot of APIs in Kubeflow to support different schedulers. So I was kind of playing devil's advocate to ask for a more unified solution that doesn't involve importing all these dependencies in, at least in MPI operator, but the same thinking extends to the rest of Kubeflow. And the main problem is that if we move the dependency out of MPI operator or the dependencies, then it means that on the other side, the schedulers have to add the code to support the pod groups, the schedulers need to add code to handle the specific job objects. In this case, the MPI job, TensorFlow job, and so on and so forth. So in a way, the dependency nightmare switches from one repo to other repos. And in general, I guess this is an end-to-end problem, right? You have n schedulers, you have m jobs, and there's going to be this dependency nightmare somewhere. So I was advocating for not having this nightmare in Kubeflow, but then it's unclear what the correct solution is. So it's a long thread, but one of my proposals was that, okay, so if we look at the Kubeflow objects, let me just share that real quick. So if we look at the Kubeflow objects,
so this is only for MPI operator, not for other like training operator, right?
they all look similar, so that's the good thing about it. They all look the same, rather. So there's this object called run policy, which is in the spec. So MPI job spec, and similarly, other specs have this run policy field. And then within the run policy field, there is the scheduling, I think it's called, scheduling policy field. And then the scheduling policy field, does it work? The scheduling policy field is the one that is being used to build the pod group, the volcano pod group. But given the fact that they all look the same, I'm thinking that this is some form of this makes it not relative. This makes it somewhat easy to support all of Kubeflow's APIs with one piece of code, quote unquote, because there's dynamic, I guess, dynamic informers and things like that that still need to be set up. But once you have all of those set up, you still can unmarshal into this object and use this information to build the pod group. So this is just for Kubeflow, right? If we, I don't know, we think of Ray or we think of Spark, likely they don't have this unified spec. So that's still a problem. So again, to summarize, my overall idea was that, well, we have these similar specs, so there could be a separate controller or even the scheduler plugins themselves that can use this API to build a pod group. Then there is no dependency of MPI operator into cost scheduling plugins. And with that, I would probably also advocate for removing the Volcano code from MPI operator, pushing Volcano to do the same, to buy the problem basically. So buy the problem of having to deal with this integration. And my hope is that, of course, this is not maintainable, right? It adds a lot of burden. But if we put pressure on all these implementations and all these schedulers, hopefully there is enough pressure to push for a unified solution. And there is already a couple of solutions that were started a long time ago, but not completed. For example, the idea of having a suspense sub-resource. Or you can rename it to job queuing sub-resource, or I don't know, there can be other names. So CRDs would be able to advertise that they are schedulable as a group and things like that in a unified manner. I guess in a unified manner. Or the other alternative, which is to actually upstream the scheduling plugins pod group API into main Kubernetes, which last time we discussed, it was pending on a better understanding for auto-scaling and the usage of the what's it called, pre-enqueue extension point. So anyways, I don't expect that we will be holding from doing just what we have been doing, which is add the cost scheduling plugin dependency in the operator. But at least I wanted to, everybody to still have to think about the bigger picture, and that what we are trying to push for is not maintainable for any project, whether that's Kubeflow or scheduling plugins or Volcano. Yes. So that's the summary of the discussion. But if you have any thoughts now, or if you want to go into the issues and share your thoughts, that would be great. or if anybody wants to start designing or thinking about these solutions about a sub-resource or upstreaming the pod group, that would be great. Anyways, I'll stop here for questions.
Yeah, basically, how many operators are there supporting, are using the same spec like scheduling policy and leveraging the pod group? MPI operator, training operator, anyone else?
So in terms of repos, it's 2. In terms of APIs, there are more than, I think there are like around 5 or 7.
Mm-hmm.
There is TF job, PyTorch job. I don't remember the other names, but they all share the same code, except for MPI operator. It's a separate code, repo. The rest share the same code. So they look the same. Yeah, I guess the good thing about this scheduling policy struct is that, well, it's kind of serving as a playground. Maybe that's all the fields we need. Maybe we'll discover that we need more fields, and then maybe this scheduling policy can actually also be upstreamed or be part of this super resource that we define for jobs.
There's one third long-term option, which is the API that we're still designing, the job set API. If we can use it for everybody else, and then all these parameters would sit in the job set API that creates the pod group, you would create that, potential unification. But again, all of the solution needs convincing and like collaboration from different repos. Like it's either, for example, these repos to change the way that you described, advertising a sub-resource or whatnot, or building on a unified API that handles all of this for everybody. So I guess the one piece is not having a unified API for launching batch jobs, basically.
Yes, right. So this is a discussion we should probably continue having in the working group batch as well. And yeah, it's going to be a long-term investment anyways.
All right. Last but not least, where you're proposing to score nodes. What do you mean?
Yeah, 1 second, let me share my screen. So I think this is one idea, maybe you or Aldo mentioned a little bit before. So yeah, the background is that we do have score plugins. And when users ask, how can I desire this behavior over the other score plugin? Our official answer is to use the weight for the individual plugin, right? So that's correct. But don't forget that we have the percentage of nodes to score. So let's think about this, a simple case. Suppose we have a 20 nodes cluster and the percentage of nodes to score equals 10%. Just simplify the real logic that we have a minimum 100 nodes to score, but just forget about that. It's a simplified case. It says that 20 multiplied 10% equals 2. Okay, says we have a deployment with 2 pods and they have the preferred pod affinity, says they want to co-locate to the same node together. And then pod A1 is scored in a small scope because of the percentage of the node score. So it's evaluated node 1, node 2. So it randomly, let's say, land on nodes 1 and 2. So for pod A2, when it comes, it do want land on the node that part A1 lands. But internally, we have a scoring index randomly move by one position, and then as time goes, it can land starts with any index. Let's say, okay, this time when part A2 comes, the evaluation scope is node 6 and node 7. So in this case, the preferred path affinity primitive is a node OP because it cannot evaluate the node 1, node 2. It's a red cross here, so that the part A2 land out randomly. And so the scoring plugin doesn't work at all in this case. So this issue is pretty obvious in an idle cluster, because idle cluster you stop upon you reach the sample size, right? But in a very busy cluster, you maybe just need to go through all the nodes to reach the sampling size. So that is what I observed in our internal production cluster. So this is the, I would say, this is one case. And there is another case. So this case is happening on the scheduling primitive we provide on workloads on PAR. And there can be some other scenarios like the scheduling primitive was applied in the node. For example, the preferred node schedule tint that can apply to the nodes. Let's say node 15 and node 20 have this kind of preferred node schedule tints. And when the PAR comes, in reasonable schematics, this part doesn't want to be scheduled to node 15 or node 20 because maybe these nodes are being being some maybe customized situations that they don't want incoming paths to land on, but they don't want to put a strict node schedule tint, but prefer. But in this case, again, when the scheduling internal scoring index lands on this, and maybe just pick up the exact nodes with the preferred node scheduling tints so that the path lands on them. So that is also not ideal case, which makes the preferred node tint is just a node OP. So what I want to propose is that to have a way to have the schedule plugins to offer option to sort this kind of nodes. Like in our pre-filter, right now we enable the user to provide a list to say, okay, you must and only must try this nodes, right? That is the situation. There's basically no sorting there. It's just a must-do list. But in this case, it's a prioritized list. Some nodes I want to be prioritized, and some nodes I may want to deprioritize. So providing a sorting function out there can make the sampling logic more accurate. So this is basically my idea, and this logic should be applied to the pre-filter either through a parameter or through some like pre-filter extension, something so that can provide a sorting function. So the pre-filter plugin can implement that. So that is a very basic idea how to resolve this issue. I think Abdullah, you used a long time ago with some similar idea.
I don't recall.
Okay.
But I think but I do acknowledge this problem. I mean, scoring is completely unpredictable, and we've seen a lot of cases where people are just basically assuming that if a node exists with the preferred assignment, that the scheduler will actually pick it. But for a very long list of reasons, the scheduler doesn't. One of them is obviously this one. It's like we are always looking at a subset of the nodes. Right?
Yeah, exactly.
I mean, we tried to fix the weighting issue between scoring plugins, but this one I think is a bigger problem, right?
Yeah, so basically it provides a new scheduling machinery to our scheduling framework, not only beneficial to our in-tree plugin, but also to the out-of-tree plugins.
Yeah, and I agree. This needs to be like, I mean, in the extreme case, you want to run score before filter, and then so that like you have a higher chance of actually picking the right node.
I will come up with a sort of design document on this. And basically, there's some implementation options. I can evaluate which one best fits.
But I think intrinsically, this is gonna hurt performance because basically you need to evaluate all nodes in a way.
So basically, it will, if we provide that as a sorting signature, it basically is that the plugin opt-in. Yeah, it will sort of, you have to do a round of sorting for each pass scheduling. Yeah, that's definitely.
But and also, what happens when two plugins have sorting?
That's a good question. That's a good question. So that is why I was. Yeah, go ahead.
Yeah, that's why I was thinking. Actually, like in the extreme case, you want to run score before filter, because score merges the scores.
No,
right?
no. It's not score before filter. It's just.
I understand what you're proposing. I'm just saying that, like, in the most extreme case where you want to handle all the corner cases, like the one that Aldo mentioned, is basically run the score before and then apply the filter.
Another question I will have is, why is sorting better than simply doing 100% percentage of nodes to score?
Oh, no, they're not in conflict. They're working together. It's just the amount of this percentage nodes to score. I want to prioritize some nodes. Otherwise, I cannot find the design nodes I want. It's basically the path sampling is pretty random. That's the key issues here.
But how do you prioritize them without looking at
just
all
give the machinery to the scheduling framework, so user can choose how to implement that. For this case, when the part A2 comes, I will see, okay, it carries the preferred path affinity. So the path affinity, inter-path affinity plugin can implement the contract to say, okay, I want to prioritize evaluating node 1 and node 2. And I'm fine that these two nodes doesn't fit for part A2. So I go to the other node. But if these two fits, I want to give it a pretty high score. No, so basically give it a high score is another context. Basically, I want to evaluate these two nodes first. Not in this case, these two nodes are not evaluated at all. So that's a key issue here.
Yeah, but assuming, let's simplify and assume one, just the only exists one score plugin. So sorting, why is sorting different from scoring 100% of the nodes? And
100% nodes can achieve the same goal.
Right. So, but then sorting implies that we need to look at all the nodes.
Yeah, if you specify 100%, there's no meaning to do sorting. It's just to have this co-work with the sorting, not 100% case.
How do you calculate the sorting without looking at all nodes anyways?
You have to look at all nodes. You have to.
Then what is the advantage over just setting 100%?
Because you could have a heuristic to pick them up at a lower cost, potentially.
Okay, sorry, say it again.
This one.
You could potentially have a heuristic that iterates over all the nodes, but doesn't really need to have as expensive as the scoring. Something much simpler, potentially, to sorting, like depending on the plugin, of course.
Yeah, this is a global or profile-specific configurator. That means for all this profile, you have to sample it 100%. This is not the ideal case.
I guess Aldo's point is that is there is it possible that we can sort at lower cost than scoring all the nodes? So
yeah, that can be an optimization. That is why another possible option is to ask the scheduling plugins to return a list of prioritized node list and maybe a deprioritized list. That can be another implementation option. So basically, I will in the proposal, I will list all the options here. Sorting is one. Just simply giving a return a list is also one, and maybe some others.
It's not about it's not about the API. It's more about we understand
not
that.
API. Yeah, go ahead.
Yeah, it's not about that specifically, but is it actually feasible? And giving concrete examples of for example, preferred pod anti-affinity to produce that list at lower cost than doing 100%.
Yeah.
Because asymptotically, it's on. I have to go through all the nodes. But I think the difference is in the probably most likely the constant. And that could make a big difference, whether or not you want to go 100% or you want to do a pre-filter identification of that.
Yeah, basically, if we give this option to choose which nodes are prioritized, it depends on how the implementation and how the interface we give to them. If we say, okay, just name the nodes, that is one contract, so that they can basically use some kind of pod selector, node selector to give us the node list. On the other hand, if we want the contract more generic, maybe sorting. It's just a big O(n) login operation cost.
But again, I don't think it's that. I think it's more about how you produce that list, whether it's sorted or an explicit list. You have to go through all the nodes. You have to compute something to produce either the set, the subset, or the sorting. Is that computation going to be less expensive than actually scoring the whole thing? Like running the score on all the nodes. You see the point? It's not only about the contract, the pre-filter or whatever extension that you're going to run before filter to produce that whatever prioritization or a subset of nodes.
Yeah,
it has to go through all the nodes anyway. So it is an O(n) operation, something similar that would to the score if we are running at 100%.
I would say sometimes there can be still some performance gains comparing to a brute force 100% scoring. So yeah, let's see how the proposal can resolve your concern, comparing the net benefit comparing to the 100% of nodes to score solution.
Because I mean, in general, actually filters are less expensive than scores. But I guess, that depends on the plugin, which exact plugin is actually asking for. The other concern is that we've optimized quite a bit that loop to not do map lookups, etc. And this sounds to me like something that would add these kind of overheads back. If you remember iterations over sequentially or going all over the node list and whatnot.
I think the design has to include specific examples and not just how the API looks like. Because if it's gonna end up costing the same amount of CPU as just scoring 100%, I don't see a reason why we should do it.
Another benefit is that right now the 100% this configuration is per file, not per plugin. So if you want to just tune particular plugins, you have the benefit, right?
I wonder if something along the lines of just like making the percentage per score would be enough, but I'm not sure how.
We're running out of time. I think the next step is probably a proposal here.
Yeah.
All right. Thank you, everybody.
Yeah, thank you.
Thank you. Bye-bye.
Bye.